is between negative 1 and 1.
No, that's wrong.
What? I have first derivative. That's my second derivative.
Oh, second derivative between 0 and 2.
Yeah, second derivative is 0 and 2. Oh. What's her second derivative? 12 minus 2. What's that? Wait, did I record? What was the original price?
Wait, you
I
got
forgot a square on it.
Oh, but look at that. Look at this.
Copy
You guys
is
draw
wrong.
both computers. So I need to have to do with this then.
It's very stupid.
Told ya. Bang. See? Take that back. Right. Yeah, see? So it's not a point. It's not. It's a point. No, wait. Yeah, it's a point of inflection. Oh, wait, yeah, it's a point of inflection there. So you got a point of inflection at 0. Okay. Right? I don't know how you can sketch it though. So you have a point of inflection at 0, okay, and then you have the other point of inflection at 2, and then you have a local negative, a local min at 3. So it would be something like this, right? It'd be like, do we point of inflection here? And let's say we got a local min at 2.
Is 0 a point of inflection?
Wait, no, it's decreasing to 0, and then you get a point of inflection. No, we're trying to grab f of x, not the derivative of f of x. So it's decreasing here, and then it hits a point of inflection, and it keeps decreasing, and then it hits another derivative. Oh, it's gotta hit this point of inflection first. Yeah, so there, and then like that. It's got this, right? There's point of inflection.
Yeah, that was the. I copied this wrong. I forgot there's a square there. So this should be x equals 0 and 2.
Is this your first derivative?
There's my.
No, that's the second derivative.
Where's your first derivative?
Right.
Okay, yeah, that's fine.
Right here. Wait.
So
Oh, first derivative.
this is your first derivative.
That's the second derivative.
Okay, but what do you need to know? So what this graph asked you is for intervals of increasing
said-
and decreasing.
I said 0 to here, and I got x equals. Oh, where did it go? X equals 3 and 0.
Okay. So where's your sign analysis for this?
The graph looks like.
Not yet. I went straight for the second derivative. I
Okay.
had to do the
Okay.
that one.
Yeah, this can only be that makes sense.
You look like you have 2 concave downs in a row. That's a little picky, but flip that, reflect that curve a little bit. Good.
Is x equals 3 the only definition we have?
How do you know?
Because 3 is on the, because 1 is greater than 2, and the second derivative is positive, it's concave up, and because 3 is on the concave up side, so,
So why is 0 not an extrema?
because 0 is, it's always concave down from left and right, so it's
Correct.
a point of inflection.
It's not that it's concave down from left and right, Shukai, it's decreasing from
Oh,
left and
okay.
right.
Oh, okay.
That's different. That nomenclature is gonna be important on the AP.
Oh, okay. Decrease.
I didn't say it was hard.
Are we meeting today or no?
Yeah. No. Yeah, 10.
Okay, because
Wait,
one?
no, I canceled that.
Okay,
I
that's
don't
what.
know. I don't know. We're going with my computer with me.
Because Brian had said something about he was meeting with you too.
Yeah.
But since we met yesterday, we don't need to meet today.
Yes, I think that's what we decided.
Thank you. Then I'll do more observations. Thank you.
Perfect. That's what I need to be doing. Okay. So,
Whoa.
for your first derivative, what did you get as the extreme points, Michael?
0 and 3.
Correct. What did our sign analysis tell us about 0, Spencer?
It's negative on both sides of it until it hits 3 ends, which is the positive.
Okay, so what's your conclusion about 0 if it's, and instead of negative,
It's a
well,
point of inflection.
negative refers to your sign,
So it's decreasing.
correct, better? Okay, so say that again.
So it's decreasing on both sides of 0, so it's going to be a point of inflection. And then when it hits 3, the graph will just increasing, so it's going to be closer.
And be careful here, just because 0 is decreasing on both doesn't necessarily mean that it's a point of inflection. I'm not sure. It means it's not a local extrema.
Yeah.
So that still has to be verified by doing your second derivative. That does turn out to be the case here, but there probably is some case where there isn't that we can't think of. Okay? So second derivative, what did you get for your second derivative, Shukai?
Second derivative would be 12x squared minus 24x.
Okay, what were the critical points for the second derivative, Michael?
0 and 2.
Okay, what did we learn at the point 0 based on our sign analysis, Michael?
It's a point of inflection
Okay, how do you know?
because it switches constantly from up to down.
Very good. And then how about at the point 2, Spencer?
Switches concavity from down to up.
Okay. So Spencer, you asked me a question earlier. Can you repeat that question? You asked, can we plug it? Should we find in the points?
Oh, yeah.
And what did you say? You answered.
You could, because to find the antiderivative, it'd be plus c at the end.
Right. So what actually is true is that this is one possible graph of this function. It could also look like this. It could also look like this. How many possible graphs are there of this? Infinitely many. What is true graphically about?
It's like the
Say more. I don't know what that means.
it's gonna show not the actual
Right. So remember plus C for your algebra 2 days. A plus C after x not included in the exponent is a vertical shift. So the same thing happens with your antiderivative. A plus C on your antiderivative is a vertical shift of your graph. The shape of the graph isn't stretched or shrunk, and it's not a horizontal shift. A plus C is a vertical shift in your graph. So this is what your graph looks like, and then there are infinitely many graphs of that shifted either positively or negatively across y's. Okay? Adios, guys. I'm glad to hear you guys already got your homework done and feel good about it. Okay. Well, you too.